Let's look at the other variance question. It's a luck of the draw lah. The previous one got an easy, simple harmonic motion question, but a difficult electric field question. This variant got a difficult, slightly more challenging, simple harmonic motion question, followed by an easier electric field question. Always a roll of the dice. How lucky are you? Don't know. Okay, so in this question, we did a simple harmonic motion. Maybe only this one a bit jump scare. But this one, all lines means pain, brain pain. Okay, let's do the question. This is Winter 23 P41. Okay. Define electric potential. Work done per unit charge. Positive charge. Work done per unit positive charge when moving it from infinity to a point in the electric field. No short form. Okay. So part B, two isolated charged metal sphere, X and Y, are situated near each other in a vacuum with their centers 24 meters apart. Point P is at a variable distance X from the center, joining the centers of the sphere. Okay, so let me draw some diagram to give context, okay? I know, or at least I hope you know, that the potential inside the sphere is 0. So I have a sphere here. There's a sphere here, it's a tiny sphere, not too big. It's in place. And then I have another sphere here. Big one, bro. Something like that lah. Ish. No, it's not very spherical, but can lah. Okay. The centers are 24 meter apart. There's a point here where it is 0. Inside the potential is also 0. Inside the potential is constant. All right. State 3 conclusions that can be drawn about the spheres in figure 5.1. I just made a conclusion, the radius. Anyway, the conclusion may be qualitative or quantitative, i.e. you may use numbers or you may use words like bigger than, smaller than, etc., etc. Okay, so I think I'm going to talk about the radius first. Because I don't know. Just normal. So the radius of sphere AX, point P is at a variable distance X from the center of X. Okay, so this is X and this is P. P we measure from here. This distance is X. Okay, so sphere X radius is 2 meters and sphere Y's radius is 4 meters. 4 meter radius, meter radius. Okay, radius of sphere X is 2.0 meter, 2SF. Radius of sphere Y is 4.0 meter. My friend, you just write about sphere X, you get 0. You just write about sphere Y, you get 0. You write one statement about X and one statement about Y, you get 1 mark lah, instead of 2. So if it's a list rule, my first comment is try to provide a detailed A and B description. They don't always need that from you, but when they do, it really hurts that you didn't get full marks because of that. Okay, so the first pointer here is statement. Each statement should have both X and Y. Something about X and something about Y. Okay. Speaking of this, what do you think about the charges? Let's talk about the polarity first. If this V is negative, meaning Qx is negative. Because V is a vector, whenever we look at electric field for vectors, we substitute the polarity. This V is positive. So Qy is positive. Same reason, no? So please don't write charge of X is negative, then the third point charge of Y is positive. You're wasting your points. Put it together. Charge on X, sphere X is negative, but charge on Y is positive. You could obviously also say that the spheres carry opposite charges. Just like for the first one, you could say sphere Y is twice the radius of sphere X. But I prefer to just write them out clearly this way, just to be safe. Right? Last one. What else to talk about? Okay. Besides the region of constant and then the positive negative sign. If you do maths, you should be able to know that most of the time the x-intercept have a lot of meaning. For example, this 12. So if I already compared, because I need to compare the sphere, I can foresee a lot of students, if I'm marking this paper, would write things about the electric field. So they will tell me things like, oh, the electric field or the potential is negative, eventually becoming zero, and then positive. You never describe the sphere. I need you to talk about the sphere. Don't talk about the field. Don't talk about the potential. I don't care about those. The question is asking for the sphere. So now I need to think about the sphere, okay? I got the charge, polarity, but can I talk about the magnitude of the charges? How do I know which charge has a greater magnitude? If you're thinking that, surely X got greater magnitude, right? Because X is more negative. No, hence need to calculate. But here's what I do know. This 12 is an important point here because at X is equal to 12 cm, Vx is equal to Vy. But then this one is Qx, Qy over 4 pi epsilon naught Rx, 4 pi epsilon naught Ry. Rx is here, 12 cm. Ry is measured from center of Y, also 12 cm. So everything is equal, right? Rx equal to Ry, because midpoint, or sometimes the mark scheme would like to say symmetrical, but it'll be hard to see the symmetrical. I can see a symmetry, but then you may argue that this Qx is more negative, so maybe not. But I can always plug into the equation. So if Rx is equal to Ry, everything else is the same. Hence, Qx will be equal to Qy. So magnitude of the charges on the spheres are equal. I use equation 1. Magnitude of charges on both spheres are equal. I use Vx equal to Vy at 12 cm. Okay. Some students may be thinking, can I not take the surface leh? Can I not just take like, I take this one, or I take this one? Cannot. You know what's the problem with taking this one? I'll show you why. You won't get exactly equal. Now, as I show you why you won't get exactly equal, maybe you can think about it. Why is it that it won't be exactly equal? Okay, to make my life easy, I'm just going to call this 1, 2 now, okay? I don't know what's the relative magnitude. I'm just going to click 1. If I do the 1, 2 thing, then this one, halfway, but not really. A bit more than half. So hard to read, bro. Okay, so that's the first problem, lor. Very hard to read. It's half a box, but not exactly half. So should I take 9 boxes or should I take 8.5? I think by reading your mind, if you are not yet asleep, I will take 0.85. 8.5 boxes, okay? So you could say, sure, instead of using when v equal to 0, can we not say at the surface of x, Vx is Qx over 4 pi epsilon naught Rx. So Vx is 2 or negative 2. This one will be negative Qx because the charge is negative. Yeah, let's omit the negative now, okay? Then this is 4 pi epsilon naught. The radius is 2 as well. So Qx is 4 times 4 pi epsilon naught. And then I repeat again. At surface of y. Don't know whether you can tell. This does not bode well. Qy is 4 pi epsilon naught ry, radius of y. So this would be 0.85. Now what is Qy? 4 pi epsilon naught ry is 4. What is 0.85 times a 3.4? 4 pi epsilon naught. Sure, you see the charge equal, meh? You know why they are not equal? Because they are not far enough apart. When you are standing at X, there's a little bit of Y disturbing your electric field. When you stand at Y, there's a little bit of X disturbing your electric field. So actually, if you really want to do this, you need to take this plus Qy over 4 pi epsilon naught bracket 24 meter. And then here you need to add Qx over 4 pi epsilon naught 24. Is it 24? Sorry. 24. You are not 24 away from the surface. You are 22. Sorry, yeah? Not 24. It's 22. 22. This one would be 20. Right? The surface now. See here? The surface is at 20. I don't know about you, but I don't feel like doing calculation anymore. Because it's a lot of work for that 1 mark. So always monopolize my personal favorite number. 0. This is best. Because they are equal, cancel, and check. Okay, so the reason why these two is not exactly equal because you are missing a term at the back. Right? Unless you have no other information, then too bad, no. Okay, so I guess what you could do is you could look at the past year and practice a bit by looking at those graphs. If you're considering the surface, cannot because there's a little bit of y on the surface of x, there's a little bit of x on the surface of y. So that explains why if you do this, you won't be able to get exactly 4. It's 4 and 3.4. Okay, that's the 3 marks. Hard work. All right. If I've never told you before, here's word reminding. Here is a list. So 1 point per statement. If let's say you say radius of sphere X, radius of the negatively charged sphere X is 2.0 meter. Radius of the positively charged sphere Y is 4.0 meter. You squeeze everything down here, you may, I think you may lose marks. You may lose 1 mark because you didn't separate them. So don't do that. 1 point per statement, no extra statement. They will mark the extra statement, but they won't give you marks. They will only mark the extra statement to make sure you don't contradict yourself. So if let's say I'm not very sure whether the magnitude of the charges on the spheres are equal, so I just want to tembak, I write here, magnitude of the charge of X is greater than Y. This is wrong, but this is also wrong because they contradict. So equal or greater, contradict. So 3 and 4, both automatically wrong. You write more, we will read, we will mark, we will find if there is contradiction, then both or everything that is contradicted will be cancelled. Don't write extra points, just write 3 points. Make sure the points are clear. You're talking about only one thing and you're talking about both spheres. All right, this is to safeguard your marks. Okay, part C. A positively, yes.
So if you write 4 things and then one of them is wrong, but then they don't contradict, do we get full marks?
No,
You would take the wrong one.
they will mark the first 3 points.
Okay.
Only the first
thanks.
3 points can get marks.
Okay, thanks, miss.
So it's not in your benefit to write more. So if it's wrong, if it's correct, wrong, correct, it's 2 marks. If it's correct, wrong, but no contradict, you can still get 3. Okay, last part. Positively charged particle is placed at point P at 12 meters, and the particle is released. Describe and explain the subsequent motion of the particle. Hang on, let me yoink the graph over. I need to yoink. Okay, if you really understand electric field, right, this graph is very nice one. It's basically like a slip and slide, but for particles. It shows you what happened if I put a ball here. If I put a metal ball here and let go, the ball will fall down. So it will fall this way at increasing acceleration because the gradient is getting steeper and steeper. That's my answer. That's my very intuitive answer. If I put a particle here, it will slide down the potential gradient, slide down the gradient at increasing speed. So my answer will be move towards particle X with increasing speed. Okay, if let's say that's not where you are at, that's fine. Okay, we already deduced that charge X is negative and charge Y is positive. If you put an alpha here between a positive charge and a negative charge, we definitely know the positive charge will be attracted here lah, okay? In fact, it will be attracted there stronger and stronger. Because as it is closer to the negative charge, the field becomes stronger, so the force becomes bigger. So by the time the alpha is here, the force becomes extra strong. Okay? If let's say this one cannot, then think about the gradient. Gradient here is steeper than the gradient here. So in this direction, potential gradient magnitude increases, steeper. Electric field strength increases, electric force increases. Negative gradient is because it is to the left. Okay. Describe and explain. My hand tired, so I'm going to type. I could say that the particle, because alpha particle, is positively charged and will be attracted to negatively charged and repelled by positively charged Y. So because of this, because this is the explanation, right? So hence alpha particle, oh sorry, it's not alpha, it's a positively charged particle. Fine. Hence particle will accelerate towards X. Or you could say to the left. Okay. With increasing magnitude of acceleration. So it will accelerate and it will accelerate more and more. So because of this, particle speed or velocity will increase at an increasing rate. Okay. You mentioned that because need to explain, right? So this is the explain. To know how something is moving is to check in with Newton, right? Newton will tell you how things are moving. Okay. And then after that, you describe, you explain something like attracted to negatively charged Y, repelled to positively charged. So attracted to negatively charged X, repelled by positive charge Y. This is 1 mark. Is it B1? Is it B1? Yeah, it is B1. So particle will accelerate towards X to the left. This is already good enough to get B1. And then increasing magnitude of acceleration. But because it's motion, so I always tie it back to speed 1, just to make the whole story complete. How does the force behave on the positive charge? How does it affect the acceleration? And how would that affect the speed? So I think sometimes if the question is too difficult, they can adjust the mark scheme to make it easier. And when the mark scheme is easier, then you will see a lot of B marks floating around because basically the student GG. Yeah. So the examiner was trying to be nice. Okay. So it says here, let me now. Part C. This was the most challenging part of the question and one of the most difficult questions on the question paper. Some candidates mentioned that the positively charged particle moved towards X, but did not say why, and did not give detail that the particle will accelerate. So if you think about your trial paper and you couldn't answer the question in the gravitational field, that is also the most challenging part of the question. Generally, people don't know what to explain. Okay, so here's what my suggestion is. You go and look at the graph, go and pick up some graphs and then have a discussion with your friend. Oh, I put an alpha particle at 12 cm, what will happen to it? If I put it at 20 cm, what will happen to it? If I put it at a V graph that looks like this, there's another V graph that looks like that, right? Ooh, what will happen to it? My general answer is, imagine this graph as like a skater ring. Whatever you put, whatever positive charge you put, confirm will go to the left. Then teacher, what about negative charge? It's reverse, it's opposite day for negative charge. So whatever happens to the positive charge, you just reverse it for the negative charge. Okay. So sometimes they will test your ability to interpret this graph. And if they ask you, you can't run now, you have to be able to interpret it, or else how to answer questions like this.